Right, yes, I am suffering one of the worst hangovers I have ever had in my life. You're making the mistake of trying to rid the beer factory of all of their beer and not eating anything beforehand. Anyway, okay. As developers, our responsibilities to the web, the things that we need to know, the things that we do, this is something that keeps changing. You know, we get more and more responsibilities as time goes on. And if you think back to the start of the web, it was just text on a screen, right? And our goal was to have that text be read by someone else. And that was actually quite tough, right? Because there wasn't really anyone else on the internet. But then there were more and more developers on the web, and we had to compete with them. You know, we wanted to show that we were better developers than they were. And we did this by putting our pages in space and centering the text and making bits move from side to side. We really liked the moving bits, actually, so we added loads more of them, you know. Make it look like there's loads of computer shit going on, because you know the more complicated it must look, the better it must be. You know, the more effort it must have taken. We also discovered JavaScript around this time, and we used it to create great dialogues. It was great. But then we looked around and we realized that the internet had been infiltrated by normal people. It was like we were having this party because our parents were away, and we'd been having this party for years, and when we were suddenly told the parents are coming home, and we're like, oh crap, we've made it such a mess, we have to clean up. So we did. You know, usability became something we had to care about as developers. Things like the GIFs, the marquees, no longer cool. We started thinking about readability, semantics, accessibility. It was a real sort of back to basics move. For the web. We got a new browser war at this time as well, and developers had to care more about cross-platform and cross-browser compatibility. This browser war we'd already had a browser war, but this one had bigger explosions and more budget. Netscape reprised its role as Netscape, but it was killed off in the first scene. But then we had the new characters like Chrome and Safari. But then we started using JavaScript properly as well. We started doing good things with it. CSS became more powerful. This was more responsibilities we had. And then our testing surface area exploded. And I think this is probably the fourth or fifth time this image has been used. This is Brad Frost's image. Developers now, we have to care about loads of different devices with different interactions and different capabilities. And this is kind of where we are now, except GIFs are cool again, as long as they're transcoded from a video and they're 5 megabytes in size and they're of a kitten chewing a rabbit. I don't know. But until fairly recently, we'd taken an odd stance on graphical performance. Our goal was usable, not good, usable. And this is on machines that could draw 3D worlds fast enough to respond to gaming controls in real time. We were happy for our 2D, fairly static pages to perform just a little bit better than unusable. That's no longer good enough, right? I mean, Facebook did an experiment where they artificially decreased the performance of their mobile app. They just sort of brought the frame rate down a little bit, and they measured a significant drop in engagement when people did this. So if you're not caring about graphical performance, someone else is going to have a similar product and they will care, and that's where the users are going to end up. And we didn't really care about this stuff before because it was impossible, right? The browsers weren't really capable of delivering a smooth user experience, but they've kind of met us halfway now. Internet Explorer, Chrome, Firefox, Safari. They've made huge surges forward in graphical performance over the last few years, but we have to meet them halfway. We have to do that little bit of extra work that lets those browsers deliver a smooth graphical experience. And developer tools are here to help us. One of my favorites, obviously, being part of the team is the timeline in Chrome. So you can reload a page, interact with a page, and it tells you what's going on in the background, all these things that are happening. But what are these steps, and what causes them to happen? How does the browser get from data to pixels? Well, in the beginning, there is nothing, right? And then like a burst tap, the browser is sprayed with HTML text from far off lands. And the browser will then convert that into a tree of elements that we know as the DOM. And this step in the process, as you probably know, is called parsing. And that will appear in the timeline, and you'll see that there. And that will happen when a document's loading, but it will also happen if you use inner HTML or something where you pass a string to the DOM and it converts it to elements. We haven't drawn anything yet, because although we've got this tree of elements, we don't know what they look like or where they go on the page. So to work this out, the browser starts with a style calculation. And this is where it looks at the CSS cascade, your style attributes, your font tags if you're from the 90s, and it works out which of those styles apply to each element. And that event shows up in the timeline as recalculate style. So that's going to happen whenever you change the page in a way that's going to affect the styling, something like loading a CSS file, changing a class name, changing a style attribute, moving things around in the DOM. Now, a couple of the elements didn't get their styles calculated here, this paragraph and this div at the bottom. And the reason was we looked at the parent element, the parent div, and it turned out to be display none. So once you hit a display none element, the children there, they don't get their style calculated because it has no impact on the page at all. So we haven't drawn anything yet because although we know what styles apply to each element, we don't know how those styles interact with each other. We need to work out the size and position of each of these elements. And we do that by creating another tree called the render tree. And this knows, for each element, whereabouts it'll go on the page and how big it is. And this process is called layout. I think Mozilla call it reflow, but it's the same thing. And that shows up in the timeline as well. So changing the DOM is going to cause a layout. Style changes will require a layout in some cases. But even just things like resizing the browser, that's going to cause a layout to have to happen. So you'll notice that these trees are kind of similar, but they're not exactly the same. So this H1 has a render object. But the render object also has a child render object that isn't in the DOM. Now, in this case, it's a CSS pseudo element, like using colon before, and so that needs to be rendered. That goes in the render tree, even though it's not in the DOM. This video element, it has a render tree object, but it also has a whole series of render objects that aren't represented in the DOM. And this is the shadow DOM of the video element, the stuff that makes up the slider and the play pause button and the volume controls. But it goes the other way around as well. So this div here isn't in the render tree at all. And as I was saying before, we looked at it and it was displaying none. So there's no point for that to go in the render tree because it has no visual presence on the page. So we still haven't actually drawn anything. This is just the rendering model. Because at some point in the future, the browser is going to decide that an area of the screen is displaying like the wrong thing, or it's displaying nothing at all, and that needs rendering. And it'll select which render objects are part of that, and it'll generate pixel data for those, and it will ship them off to the graphics card. And that's called paint. And that shows up in the timeline as well, and it shows you how long it took and how many pixels it involved. So paints are caused by visual changes on the page. So it could be a DOM change, style change, layout changes that cause that. But also things just like highlighting text, that needs painted as well. So you'll see paint events for that. And that's quite a lot for the browser to do, just to show something on the screen. And we know how to measure it, but how fast should it be? I mean, we want it to be instant, but how fast is instant? So this document comes up a lot. This is the United States Department of Defense Design Criteria Standard, which is very difficult to say with a hangover. But they say that things should happen 100 milliseconds, 0.1 seconds, after a user interaction. You want to be able to react to that in order for it to seem instant. This document's from 1999, so some of these numbers should be lower, but 100 milliseconds for a user interaction, that feels about right. Let's look at an example. So here are like a page with lots and lots of paragraphs on. So what I'm going to do is I'm going to start the timeline recording so we can see what's going on, and I'm going to change the size of this green box. And now when I hit this button, all of the paragraphs are going to become the same size as that green box. So press the button, and everything changes. And that felt pretty slow. It didn't feel instant. And we can see the spike in the timeline, and if we dig into it, we can see, okay, yeah, there's the click event, and that took a long time, 1.72 seconds. And that's way outside of 100 milliseconds. That's why it felt so slow. But if we take a closer look, if we fold that out, we can see that this layout recalculate style is happening over and over again, and that's sort of showing us where all of this time's going, and that's something we can fix. So here's the code for that. We're just iterating over every paragraph and getting the width of the green box and setting that as the width of the paragraph. So the first time we go through this loop, we go to the browser and say, hey, what's the size of the green box? And it goes, well, I know that. Here's your answer. I know that because I've just rendered it. That's dead simple. And then we set the style on the paragraph, and the browser's like, yeah, whatever. I'm not going to care about that until I need to do some rendering or whatever. But then the next time around the loop, we say, what is the size of the green box? And the browser goes, well, I used to know what that was. But since then, you've been changing styles on the page. So I'm going to have to go away now and think about those styles and lay out the page and just to make sure what size that green box is. And we're doing that on every loop, and that's what's making it really, really slow. This is called layout thrashing, this interleaving of reads and writes. And the fix is really simple. We would just read the size of the box first, set that into a variable, and then go through the loop. Do the reading before the writing. Small bit of extra code, but so much faster. I mean, same example again. Press the button and it changes. It's that big difference. And if we look in the timeline, we can prove how long that was. It was about 30 milliseconds. It's about 50 milliseconds when you include the style calculation and the layout and the painting. So if you need to read stuff from the page, that's style dependent, you need to do all of your reading before you start doing writing, and certainly don't interleave the reads and writes like I was doing there, because it's a real performance black hole. The properties that are style dependent, there's quite a lot of them. You don't really want to remember them, because it's mostly common sense, right? I mean, stuff that relates to the position on the page, the scrolling, offset top, that's all common sense. And the timeline will tell you when you're doing it wrong. The only surprise on there, I guess, is inner text. But inner text has a style dependency, because if you ask an element for its inner text, it will miss out bits of text that are inside child elements that are displaying none. So it has a style dependency. Text content doesn't have that style dependency. Also, not all CSS styles are created equal, and we have a fairly new tool in the web inspector to measure them. So what I'm going to do is click on this cog in the bottom right-hand corner and go to continuous page repainting, and that's going to keep redrawing the page and tell me how long it's taking to draw from scratch. So in the case of the output that's there, it's only taking a couple of milliseconds. I mean, it's just a load of floated boxes and text, so it's really simple. So if we add in onto the page, added a background and some rounded corners, we've added a couple of milliseconds on, but it's virtually nothing. If we add in a box shadow, there you go. But it's still only a few milliseconds, not bad at all. What if we add on a blur effect? There you go. So we've kind of gone over our 100 millisecond barrier now, and that button just that adds the box shadow feels sluggish as a result, because it's gone over that 100 milliseconds. It doesn't quite feel instant. I mean, blur's an experimental feature at the moment. It hasn't really got the performance love as some of the other features, so that's kind of why that's happening. It will improve with time. But although it's heavy to render, scrolling is still really, really smooth. And that's because it only needs to be drawn once. The blur effect gets drawn once, and scrolling is just moving those pixels up and down. It's not a heavy effect. So bringing the continuous painting back on, I'm going to add a background image in. So our current rendering time is about 135 milliseconds. If we add a background image in, there's a little spike there where the browser initially had to decode and resize the image, but it's had no impact on the rendering time for the page, because rendering bitmaps is really, really cheap, because the pixel data is pretty much already there, and it's just going to add it to the page. But something else has changed. If we scroll the document, scrolling performance has just gone straight down the toilet. So if it's not actually adding anything onto the rendering cost, why have we broken performance in such a big way? Well, we need to look at another tool for this. We need to add paint rectangles. And what this does is it shows us when and where paints are happening on the page. So if I click that box, you can see as I resize the page, so parts are going to flash red. So as I select text, as I say, that causes a paint to happen, so you can see that happening on the screen. But when I scroll, it's just the scroll bar being drawn, because scrolling is just moving that layer up and down. It doesn't require repainting. But if I add the background image in and scroll again, it's drawing the whole page on every part of the scroll. And that's because it's a fixed background. The background's not moving with the content. It's using fixed backgrounds in CSS. Because if I switch to a normal background that scrolls with the content, scrolling performance becomes 60 frames a second again. So avoid fixed backgrounds, right? Because they cause too much painting on scroll. That's a little bean from the can of Jake's tips, and you're welcome. But take a closer look. Look at the best before date. It is today. My partner and I have this argument when this happens, because as far as I can tell, she seems to think that the food is fine, and then midnight strikes on the best before date, and all of a sudden it is just deadly poisonous now. And if you so much as touch it, your face will fall off, and spiders will hatch out of your neck, or whatever happens. But no, it's just best before then. It could still be fine. It's probably still fine. Browsers develop so fast that a fix for that issue with the background, that could have been committed during this talk, or today, or yesterday. So when people tell you performance tips like that, you bear them in mind, because they can help a lot. But when you use them in a project, give them a smell first, because they might have gone off. So don't trust performance rules. Just use the dev tools. They'll tell you exactly what's going on. On the Chrome team, we say tools, not rules, which rhymes, so it must be true, right? But the dev tools are a great way to discover ways that you might be overworking the browser, or ways the browser might be overworking itself that you can work around. So when you're in Chrome, do as the Chromans do, right? Use the timeline, use continual painting, show paint rectangles, show composited borders, which we'll come on to in a bit. But there are tools for other browsers as well, and it's worth covering those. In Firefox, there's an add-on which triggers the paint flashing, and there's also they're going to be moving that into their main DevTool suite as well. And it's quite good. I'm just clicking this icon in the bottom corner, and now when any paints happen, they kind of get this pastel outline. And as I scroll, we can see that Firefox doesn't suffer from that fixed background issue because the content is moving independently from the background. It's not causing a whole page repaint. So I don't know. I don't know if you've looked at Safari's DevTools. I've given them a go. I think they're awful, to be honest. Lots of little tiny hieroglyphic icons. I don't know when I press them if I'm going to inspect the DOM or open a Stargate. I have no idea what it does before I press it. But they've been busy fixing that in the WebKit nightlies, and I urge you to try those because they're doing some really exciting stuff as well at the moment. And yeah, it's been a big cleanup, and they're really good now. You can also get some extra paint debugging stuff in normal Safari if you run that line there. So this is the new WebKit debugging tools. If I inspect an element, there's a tiny little button here, which is still maybe slightly misleading, but show compositing borders. When you click that, you get this paint insight. So that the page is split up into a grid, how it goes on the graphics card, and that number there is the number of paints that have happened in that region. So that will show you sort of where the sort of hot areas of your page are. The bits are requiring a lot of painting. So as you can see with the scrolling there, it wasn't suffering from the fixed background issue. Safari does have the problem, but they're working on a fix in the WebKit nightlies at the moment. Doing paint debugging in Internet Explorer is a little bit more involved, but I do urge you to give this a go because it's worth playing with. Not so much on a page like this, but if you go to something like twitter.com/IE, and if you click on this button and type in, "Hi, please, can we have some paint debugging tools, please, thank you, bye," then hopefully that will make paint debugging tools happen in IE 11. So I urge you all to give that a go. It's easy to make fun of IE, right? But seriously, have you tried IE 10? And I'm kind of speaking to the Mac users in the room especially, but go and find a medium-powered PC and play with IE 10, because it's so good, especially in terms of rendering performance. They've done such a good job there. IE used to be a dick. We've all felt that. We've all been on the receiving end. Oh, sorry, I didn't mean that. Oof. I don't know how I can continue from that. Anyway, yeah, that team have been doing great things, so don't tar them with mistakes of the past. If you struggle to remember which versions of Internet Explorer are dicks, here's an easy way to remember. It's the versions less than or equal to 8. There you go. But do ask them for painting tools, because they are listening, and they're, the more of you who say that, they will listen, and I'll add in those dev tools because they're doing great work. So yeah, look at what's happening in every browser, because each browser has their own quirks. I picked a bug or a quirk in Chrome with the fixed background issue. That's also in Safari. But other browsers have their own quirks as well. I mean, here's Firefox. When I spin this box, whenever it just goes above the line there, it's re-rendering all of the text beneath it. So that's odd, but that's something that the dev tools will show you when it's happening. In Internet Explorer, if your backgrounds are PNG, like at the top, things are much smoother than if they're SVG at the bottom, even though it shouldn't be that slow. And I'm not quite sure why this is, because Internet Explorer doesn't have the paint debugging tools to really indicate what's going on. I imagine it's doing a lot more layout work than it has to, but I don't know. So yeah, look at things in each browser and do report bugs when you find them. I know reporting bugs is a pain, and it's not going to help your current project, right? Because you need to ship tomorrow, but it might save your next project because that fix will hopefully hit a stable version of the browser. Mobiles. If you think of mobile as special, you're probably doing it wrong. Mobile is a really big sort of UX issue. There's a lot more thinking there. But in terms of, okay, so on mobile you get touch. There's sort of different kind of keyboard access. You're on cellular data. It's got a battery. But none of those things are unique to mobile. You'll find those things in different devices. Touch, battery, whatever. Mobiles are small and they can be slower, and that's pretty much performance on mobile. That's all it is. It's just really slower. There is one difference though, and PPK was mentioning it earlier, and I want to kind of cover it in a little bit more detail. The 300 millisecond delay. So if I've got like a page here where I click it and certain bits change background, and the code for that is just using a click event, but we can really see that that 300 millisecond delay there is just so painful. It makes it feel really, really sluggish. It's horrible. We can't really leave our users with that because it's not good enough. And yeah, and that's because, yeah, you've got pinch zoom, but you also have the double tap to zoom in. So we have to wait 300 milliseconds to see if when you tap, is this actually going to be a double tap? So one way we can fix this is by using the touch events as well as the click events, because those touch events are going to happen a lot sooner. And there we go. That's instant. Brilliant. But at the end of a scroll, that is also a touch end. And that's not expected behavior at all. In fact, in Chrome on Android, if a scroll happens, it won't fire a touch end because it goes, well, okay, that's happened on a hardware level. The hardware's taking care of this event. But Firefox, the old Android browser, which this is, and Safari on iOS, you'll get that touch end event at the end of a scroll. And they're not breaking the spec by doing that. The spec is just really ambiguous there. But Microsoft have been looking at this with the touch event stuff, and on their pointer up event, they say, oh, yeah, if a scroll or a pan happens, don't fire the pointer up because the hardware's taking care of it. You would need to cancel the event sooner if you wanted to hear about the pointer up stuff. So, and that's the answer for the future, but there's not a lot of support for that. And even then, it's only going to, you can only use this fix on everything you're adding like that listener to. And that's, what about links? What about inputs? They're still going to have that 300 millisecond delay. What I'd advise anyone building a mobile site to do is use the Financial Times fast click. And once you've added that, it's going to listen to all those touch events, and it's going to fire click events as soon as it can. At the expense of the double tap behavior, you lose that. But if you're making any effort to make your site responsive, then people don't need double tap to zoom in. Alternatively, if you go for a fixed viewport, you can't scale it, so double tap has no effect. And so we don't need that 300 millisecond delay. But the only browsers that actually take advantage of this is Chrome on Android and Firefox. Even on Safari, even with a fixed viewport, you're still going to get that 300 millisecond delay. And also, pinch zooming can be quite a nice accessibility feature, so you often don't want to do that. At Chrome, we're looking at ways of, even with a flexible viewport, can we tell sooner ahead of time that when you tap, yeah, this is probably almost definitely not going to be a double tap. We're trying to find the situations where we can do that and speed up the page. But in the meantime, the FT fast click thing is your best bet. So 100 milliseconds, that feels instant. Anything over that, not so much. What the hell is that? That's not good. Oh no, don't do this to me. Right, I'm going to try refreshing the browser. Hang on, let's get rid of something else. This isn't part of it, by the way. That would be nice if it was. Come on, do it right. Okay, refresh. And let's go to 100 milliseconds. Oh, this is a problem. Right, sorry about this. I'm going to restart that browser. See, part of the thing I like to do is I always like to make my own build of Chromium when I'm presenting, because the idea behind that is, well, if I was using Canary, then that might all go wrong. So if I have a stable build, if I have a build that I can rely on and I've given this talk before, and this has never happened to me. Right, let's give this one more try. Else, this is going to be exciting. Right, come on. Let's see what happens here. Come on. Yeah, oh, thank God for that. OK, oh, Jesus. I don't need that. I'm going to get the hangover sweats if that happens. Where is my pointer? Here it is. OK. So the reason I use my own build is for the full screen to do the right thing. Let's go. Yeah, because on Lion, if you do full screen mode, your second monitor becomes completely useless. So I had to do my own build just to remove that feature. Anyway, we were talking about 100 milliseconds, right? Whatever. So this is some snow animating at 100 milliseconds, a frame every 100 milliseconds. And here is a touch action where the square there is updating every 100 milliseconds. 100 milliseconds is not good enough for animation, and it's certainly not good enough for continual tactile response. If we see our apps performing like this, we must ask what the frames per second is going on here. In that case, 10. 10 was the frames per second going on. And if that's not good enough, what is? Well, you have to excuse me, because I'm going to nerd out about frame rates for a moment. When cinema with audio was introduced, it was decided that each frame should be 42 milliseconds apart, which is 24 frames per second. Film being a series of stills where a light is shone through the film material, whatever it is. I don't know that much about it. And 24 was picked as the frame rate because film was quite expensive. And anything lower just felt too unnatural. So it was kind of the minimum. It wasn't picked because 24 frames per second was good. It was just one better than unwatchable. And things have stayed like that for like 90 years. I mean, The Hobbit being the first sort of mainstream film to sort of change that, and it released in 48 frames per second, or you could see it in 48 frames per second. Meanwhile, this was happening. People were getting TVs in their home. I love this advert where it's like, yeah, buy it. It's like having two sets in one. And if you read the rest, the justification for why it's like two sets in one is because it can do color and black and white. And that's the best marketing strategy I've heard for progressive enhancement. I wish I could take that to clients and say, yeah, my website works without JavaScript. You're getting two websites for the price of one. Right. Look, to sell cars like that, well, this car goes forwards and backwards. It's like two cars. No longer do you need two cars. One's for when you're reversing, one when you're going forward. The picture in these TVs is created by an electron gun, which is just great. It sounds really sci-fi, and it looks really sci-fi as well. The electron gun beams the picture, and it scans from top to bottom. And it does that 50 times a second here, or it did that 50 times a second here. In the States, it was 60 times a second. And the reason for that was that's the power frequency of those countries. And it was cheap to make a TV if you could just rely on the power supply as your clock, and you weren't going to get interference if you were in sync with that. So that's the frame rate that these TVs could go up to. That's their maximum frame rate. So TV shows tended to be at sort of 50, 60 frames per second, depending on the country. Although some high-budget TV shows would skip every other frame to be closer to the film frame rate, and that people started to associate that with higher quality, and that's why to some The Hobbit kind of felt like a low-budget soap opera because it was closer to the frame rate of sort of TV rather than film. Computer monitors, they could be driven at different refresh rates. 50 or 60 was quite harsh on the eyes, especially when you were sitting close. So we tended to drive them at like 75 or 100 even, but we don't use these anymore, right? So we've got TFT or plasma-based screens. And the picture doesn't scan quite in the same way as a CRT, and high refresh rates aren't really beneficial. So things have kind of come back down to 60. We've settled around there. Although you'll encounter the odd projector that wants to be at 75, and some Windows laptops, they power down to 50 when they're on battery power. But if we want smooth motion, that's our goal. We want to be delivering a new frame for every refresh of the screen. And at 60 hertz, our deadline is this, 16.67 milliseconds. That's not a long time to, edit a DOM, calculate style, layout, paint. And on a mobile, which is less powerful generally, that's even less time, or you can do even less in that time. However, most instances of animation on the web are shooting themselves in the foot. They're not starting their work early enough, or they're making the browser do more work than it needs to. So we're going to have a look at some how to schedule animation. So if you imagine that these are our refreshes, so every 60 milliseconds, you might recognize these slides, by the way, because Remy showed them yesterday. Thanks, mate. He didn't realize it was this talk. It was part of this talk. So imagine our first frame takes 10 milliseconds to construct. That's fine. That's less than a refresh. And those changes are going to be seen in the next refresh. But when should we start setting up the next frame? Maybe as soon as possible. And we could do that with code, and that would be set timeout 0. And this is how that looks, and those changes go into refreshes, and everything sort of looks fine. However, some of the frames that we created never actually ended up on the screen. We're creating too many of them, and that means we're using too much CPU, which means too much battery on battery-powered devices. And also, at some point, another process, like another tab or another application, is going to kind of step in and go, excuse me, can I have a go at the CPU? Do you mind, awfully? And so you'll be blocked for a while something else does some work, and you'll start skipping frames. So that's not good enough. We could do, so this is the sort of stuff Remy was talking about. This is how jQuery does its animation using, I think it uses a set interval, but it's basically the same. And that looks like this. So the problem here is, when you use set timeout or set interval, the number you give it, it's only going to guarantee to run your function after that time. And it uses an internal timer, which is quite rough as well. So it's not very accurate. So things kind of happen fine for the first 4 frames. And then on the next one, we're starting our work later and later into the refresh every time because we're out of sync. And then we miss a deadline, and we skip a frame. But we're still at like 58 frames per second, right? And that's pretty good, I suppose. Who here prefers orange juice with bits of orange in? So who prefers orange juice smooth? Yeah, I'm with you guys on this, actually. Most people don't. But I had this debate with someone I worked with, and he said, oh, no, I like an orange juice I can chew. He'll be over the moon when he discovers oranges. Jesus. But both are okay, really, I guess. But imagine you were drinking a glass of milk. And as you were drinking the glass of milk, a lumpy bit went in your mouth. It wasn't expected. It wasn't nice. Well, animation is like that. It's like smooth orange juice, milk, and farts. Lumps are unexpected and unpleasant. We don't want them. Have a look at this and study the motion. Follow one of the bigger bits of snow sort of down under your eyes. This is running at half the refresh rate. This is running at 30 frames per second. It's fine. We could switch to, this is how set interval looks. So once again, it's at a higher frame rate, but follow the snow with your eyes. It's really juddery, horrible, lumpy fart milk animation. This is how jQuery would do it. It's all out of sync. So even though it's a higher frame rate, it looks worse because it's not in sync with what the monitor's doing. Yeah, and that's just because it doesn't divide. It doesn't divide in. You rather than just go for the highest possible frame rate, you want to aim for something that will be divisible by the refresh rate. And yeah, as we heard yesterday, the best way of doing that is to use Requestanimationframe. And that's why Requestanimationframe works, because it's going to schedule your function call for the start of the refresh. It gives you the most time that is available to actually prepare your frame for the next refresh. And that's how that looks. So yeah, everything is, oh, there was a judder there. But yeah, OK, that's quite smooth. And if you follow the snow down, it's running at a nice, smooth 60 frames per second. And the support is pretty good. It's in all the latest browsers, especially. It's pretty new to Safari and IE and some of the mobile browsers, but it's really easy to polyfill, and you can just fold back to set timeout, so that works. As I said, jQuery does things the milky farty way, but there is like a small extension that fixes that. And if you're doing jQuery animation and you're not using this, you're doing it wrong, essentially, because this very small add-on will make it use Requestanimationframe. So the reason jQuery just doesn't have that in by default is it does present a small change in behavior. So when you're in another tab, or the browser's minimized or something like that, RAF stops calling. It pauses itself. Even if you request a frame, it goes, well, we're not doing frames at the moment, so I'm going to wait until things are visible again. But unfortunately, people had written code like this. So on an interval, they're moving a carousel to the next thing. And intervals will still run in the background on many devices, especially on desktop. So what happens is you go to another tab, the carousel says, OK, move to the next item, move to the next item. But those animations aren't running because they're paused because Requestanimationframe does that. And then you come back to the tab, and 10 animations try and happen at once, and the world ends or whatever. But this is why they couldn't just add it in by default. So don't do that. Instead, don't schedule your next animation until the previous one has completed, because then things can pause and it just works. This idea of syncing frames to refresh rate isn't new. They're doing that in the film industry as well. So we were talking about films and TV earlier. If you've got a 60 hertz screen, and this is each of the refreshes, if you wanted to show film on that, or high-budget TV shows, because high-budget TV shows are 24 frames per second now as well, things like Game of Thrones, Walking Dead, the TV show 24 with Jack Bauer, 24 frames a second, which is kind of nice. But that doesn't divide into 60. So if you're going to watch this on your laptop or like old TV, what does it do? Well, they did this, and it's called 3x2 pull-down. The odd-numbered frames are on there for 3 refreshes, and the even-numbered frames are on there for 2. Odd-numbered frames are on the screen 50% longer than the even frames, and it's noticeable. If you watch TV or film on your laptop, look for the smooth pans across, and you'll notice how juddery and awful it is. And once you notice it, you can't unnotice it. And I might have just spoiled your laptop as a media device for you. And in fact, your TV might be doing the same thing. So your nice, expensive TV, maybe it doesn't support a native 24 hertz mode. Or maybe the thing that's connected to it isn't telling the TV to go into 24 hertz mode. Netflix on the PS3 does this, and it just winds me up, because once you notice that juddery panning, or it really spoils it. We had the same problem in Europe and in the UK, because we had a 50 hertz screen, and we wanted to show films on that. And once again, 24 doesn't divide into 50. But it nearly does. Ghostbusters 2 is 5 minutes shorter here than it is in the US. Not because they have extra scenes, we just play the film a bit quicker. Go from 24 frames per second to 25, and that divides into 50 nicely. Just everyone speaks 3/4 of a semitone higher, but you don't really notice that. And films on European and British TVs were actually smoother than they were in the US, because they didn't have this alternating frame amount of time that it's on the screen. Now, I'm really worried about this because my slides are... So what I'm hoping to do now is show you the difference between software and hardware rendering. And a good example of this is Internet Explorer. So this slide is, I'm booting up a VM for this, and this crashed on me earlier. But no, it's fine. OK. So we used to do things in pure software rendering, but now we're kind of looking for I don't even know how much time I've got left because I restarted it. OK, I tell you what, we're just going to skip this demo. I am too hungover for this. Let's just. I'm joking, of course. Of course I'm joking. But this is a great example of the difference between hardware and software rendering. So in Windows XP, the screen was just one big single canvas. And the window manager knew about every pixel on the screen, but nothing more than that. The graphical representation was completely flat. So if I wanted to move a window such as this, I'd click and drag, and it would take those pixels and copy them into the new location. But then it would have to identify areas of the screen that were now showing the wrong thing. And it would send messages onto to the apps that were now responsible for those areas of the screen and say, you need to redraw yourself. You need to redraw this area. So in the case of the top right-hand corner there, that's pretty simple because it's the control panel that's underneath. That gets the message and it redraws and everything's fine. However, with the other two rectangles, the app underneath is Internet Explorer. So Windows sends a message to it saying, you need to redraw yourself, but it doesn't get that message because it's crashed. So that's how you get this effect. That's why you can sort of draw the window around. It's just this is software rendering, a single canvas that you could adjust pixel by pixel. So in modern operating systems, in most Linux desktop managers, Vista, Windows 7 and 8, OS X, they all, it's not just a single flat canvas, but rather a whole series of canvases that are drawn together by the GPU. In this system, moving a window is really, really easy, because the graphics card knows entirely what each window looks like. So to move a window, the CPU just goes to the GPU, hey, do you know this thing that you already know about? Can you put it over here, please? And it's really, really cheap and really quick to do. And then the GPU can just take everything it has and composite it together into the image on your screen. Even if a window freezes, you can still move it around, and yeah, because the representation is entirely on the card. So if you know Photoshop, think of software rendering as a flattened PSD. If you want to move something, you have to sort of edit. You have to repaint the stuff that was there before. But with a layered PSD, that's more like hardware rendering. Moving stuff is really, really cheap. So the web used to be a flat canvas, but more and more is moving to the GPU. It's about time, because it turns out that the graphics processing unit pretty good at processing graphics. And it's only now that we're actually using it. So when the browser has everything, all of the elements, it knows where they go, it will identify particular elements that it thinks deserves its own layer, its own canvas to render onto, and then they'll be joined together as a compositing operation. And you'll see that on the timeline there. So that's two paints that lead into a composite, joining them together. You can tell which elements have GPU layers by using show composited layer borders, and that gives everything that's got its own layer a kind of orange outline. Most websites will only have maybe one or two. Google Plus have been sort of experimenting with them quite heavily for performance reasons, so there's loads there. So let's look at an example. I call this snakes on the geometric plane. I like to leave a good gap there for a possible applause, but never mind. So first things first, WTFPS. Well, here's what the timeline says. This is drawing things the Windows XP way. We're doing like a full clear and redraw, and it's taking a long time. And it looks slow, and you can see every frame is over 100 milliseconds. One flat canvas. And it's just, this is driven with CSS, and we're animating top and left. But what if I were to add translate Z onto each of those little circles? We go from this to this. Like, the difference is huge. And the timeline agrees as well. You know, you can see things have gone way down for each frame. The fact that Translate Z does this is definitely an expirable Jake tip. That might change. But it works today. And we've still got some little paints actually there. That's a bug. We're fixing that at the moment. But this is drawing things more like how Vista does, more like how modern operating systems do. Each of the circles is on its own layer. So moving them around, it's just the CPU goes to GPU, move this stuff around, and it can do it almost instantly. Actually, we're still not achieving an amazing frame rate, but we can fix that as well. Rather than animating top and left, we can animate using a transform. And when we do that, we go from this to this. And maybe the difference isn't that noticeable from where you are, but if you look at the timeline, we're at 60 frames a second now. In fact, moving those 300 objects is only taking less than 2 milliseconds. So it's a huge improvement. But since we're all on the compositing layer now, we can actually make another optimization. So I've got this button here. And when I click that, some JavaScript does some stuff for a bit. And then you can see that pauses the animation. That's because all the layout work that's happening, layout happens on the same thread as JavaScript. At the moment, that might change. But if we go to our transform animation, if I click the button now, the JavaScript still takes a long time. But because it's happening on a completely different thread, it doesn't disrupt the animation. All this advice applies to mobile as well. We can see this is what we started with on the left, and just by using different kind of CSS animation on the right, things are much, much smoother. Actually, using transform gives us another advantage. On the left, we're animating using top and left. On the right, we're using transform. And as you can see, that the one that's using transform can glide between pixels, whereas using top and left, it snaps to pixels, and it looks a lot jankier. Unfortunately, in Firefox, it doesn't make this optimization. You're going to get the sort of juddery animation even if you use Translate 3D or any of the Translate stuff. And unfortunately, this is intentional. They kind of prefer this for some reason. I don't know. But you can fix it by applying a very, very small rotate. When you do, I don't know why, but when you do that, you will get smooth animation from there. It will glide between pixels. It goes onto the GPU. So layers are great, right? They're the magic bullet. They make stuff faster. Let's go back to animating top and left, and let's take away some of these styles, and let's alternate the colors. That's fine. But let's look on mobile. We can see when the color changes, there's a huge pause in the animation. And this has got Translate Z on it. If we remove Translate Z, we go to the one on the right, where it's much smoother. The thing that made it faster before is making it slower here. Why is that happening? Using remote debugging in the timeline kind of shows us what's happening. We can see this spike every time all the colors change. And that's that jolt we're getting. And that's because it's having to repaint every single one of those circles, because that's still a software operation, that painting. Moving on the GPU, repainting happens on the CPU. And this is happening on desktop, but the desktop machine is much more powerful, and it has a better pipeline to the GPU. Mobile doesn't so much. So that redrawing thing, when it happens, when all the layers are on the GPU, that takes quite a long time to transfer. Because if we remove Translate Z and go back to the Windows XP way, we get a more consistent frame rate, because we're just doing a redraw every time, and we're not having to pipe different stuff to the GPU on different frames. So if you've got content that changes a lot, you start to lose the benefits of layering in some cases. So we've seen the benefit of layers, and we've seen that maybe updating them can sometimes be a potential downside, especially on mobile. But you can also have problems just having too many layers. Maybe not on desktop, which has loads of GPU memory, but on mobile, you can have a problem. So here's The Guardian, and they've done a really good job. It's like 60 frames per second on scrolling. This is a 30 frames per second capture, so it's not even, it's better than it looks. And we can confirm this with the dev tools. We can see they're running at 60 frames per second, and they're not using a lot of GPU memory. But if I go into dev tools and I make everything a layer, so just using star, and I'm going to make translate that. As soon as I press 0 here, everything on the page is going to become a layer. So we can see that the scrolling is fine, it's fine, and then I press 0, and the scrolling just dies. And it's worse in reality than it looks on this capture, because we can see why it's happening. We've gone down to 25 frames per second, and we can see that GPU memory is hitting against its limit, and this is what's creating the slowness. Things are swapping in and out. Forcing something onto a layer is like drinking a cheap beer. There are some things that I'm better at after drinking a small amount of beer. Like speaking to people, like socializing becomes a lot easier. But even though speaking becomes easier after a beer, if I have a few more, and people who spoke to me last night will know this, I start to slur. I become worse than I would be without any beer at all. And if even more beer, it gets even worse. I went at Christmas. I went home up to Carlisle, where I'm from, and I was staying at my dad's place. I was staying in my old bedroom that he's converted into a study, but there's still a bed there. And I went out with some old school friends and got drunk in a way that you only get drunk with old school friends. And I got home, and that was fine. I went to bed, and I woke up in the middle of the night, and I was standing up, and I was at the opposite end of the room. And the part of my brain that's responsible for things while I'm asleep, I don't know, the night watch, maybe it's called, it just kind of updated me on the situation. It's like, okay, Jake, here's how things are going down. you have been sick in your dad's stationery drawer. So if you'd like to sort that out, that'd be good, and then we can go back to bed. Thanks, bye. And it was because I didn't feel responsible for this thing that I was presented. It was like a shit episode of Quantum Leap, you know. I was just like walked into this situation and was like, oh, I have to deal with this now. So this is what layers are doing. The more layers you add, your desktop's fine because your desktop can hold its liquor, whereas your phone is a lightweight. A few of these, and it's going to be picking chunks of sick out of a stapler at 4 o'clock in the morning, and it's not fun, and you don't want that to happen to your users. There are no magic rules around layering, none that will stand the test of time anyway. They can make transforming and fading stuff quicker. I mean, these slides are all HTML, and you can see most of the transitions are just moving stuff around. There's not a lot of painting. But don't trust the performance tips, just test your particular situation. So we've covered the ups and downs of layers. We haven't really covered, I'll try and briefly cover because I'm running out of time, what actually creates them. Obviously it's translate Z. The WebKit DevTools actually have got a good feature that we're hoping to get into the Chrome ones as well. It has a kind of layer list, and it shows you everything that's a layer, and it'll give you a kind of hint at why. It's quite often wrong at the moment, but it's in development, and this is a really useful tool. So here's what creates a layer at the moment, certainly in Safari and Chrome anyway. 3D transforms, any kind of 3D transform, translate 3D, translate Z, rotate 3D, X and Y, they're going to do that. If you animate a translate or a transform, or you use translate, animate an opacity or filters, that will happen on a GPU as well. Plugins, they get their own GPU layer. Canvas will, even 2D canvas, that's hardware accelerated now as well, so that gets a layer. Video will as well, especially if it's hardware decoded. Fixed position elements sometimes. This is something we're experimenting with on Retina devices because there's a big speed boost there for doing that. And soon we will fix that background issue, and we'll fix it by creating a new layer for the background image. Obviously, all of these are expirable objectives. These will change with time, but the dev tools will tell you what's going on. One that I think we heard about earlier, it was before I'd managed to make it in, but I think there was some talk of layers earlier. And yeah, if you have anything on top of something that is GPU rendered, it will go get its own layer as well. Because you can't layer something on top of a layer without it being a layer. It kind of makes sense. But that does have an effect. So here I'm going to turn on composited layer borders, and I'm going to take this square at the top. I'm going to make it have its own layer, and I'm going to move it down the page. And we can see when it goes behind the paragraphs here, they get their own layer. And then when it moves past again, they don't need a layer anymore. So creating those layers, that might be slow on mobile, but it also has a visual effect. And if we zoom in, we'll see that the text, you've probably seen this before, the kind of clear type is what Microsoft call it, or the subpixel anti-aliasing. You can see the sort of color fringing around the text, which makes it much sharper on LCD screens. And as I bring this box behind the text, the rendering changes. It goes to just grayscale. And you might have seen this before, like when an animation starts, the text rendering changes a bit. And this is why. Because the clear type stuff isn't it can't be done as a composite operation. So we have to just go to normal black and white anti-aliasing. So I think I'm going to wrap up now. I might just skip my... I don't get the point of conclusions at the end of talks. It's basically saying, hey, you know all that stuff I said? Do that, avoid the 300 millisecond stuff. Look at paints. Probably the best thing to take from this is learn the GPU. This is something that's going to have more and more of an impact on web development. Learn its alcohol tolerance. Use the dev tools. See how it works. And with that, thank you very much. Cheers.